So this video today is going to go over the CFA 6, okay? So the first question here says, use the information in the table to answer the following questions. The table shows the results of a random survey of students in grade 9 and grade 10. Every student surveyed gave a response. Each student was asked if he or she exercised less than 5 hours last week or 5 or more hours last week. Okay, so the first thing I'm going to do here is I'm going to add up some of these columns. Okay, so 49 plus 57 excuse me, is 107. And then we've got 63 plus 51, that's 114. Then over here, I'm going to do, so that's a total here. And then I'm going to do a total over here as well, okay? So 49 plus 63, that's 112. And 58 plus 51 is 109. So now, no matter which of these totals I look at, whether I'm going, so I can add 107 to 114, or I can add 112 to 109. But either way, I get 222, okay? Sorry, 221. Hold on. Yeah, because 9, yeah, that would be 221. Sorry, y'all. So that's 221 right there. So if I add the columns on the left, so if I add these two together, in other words, or if I add these two together, no matter what, I get 221, okay? So it says, for this question, choose two answers based on the results of the survey. Which of the following statements are true? So the first statement is obviously true. 221 students were surveyed because that's our total, right? It says a total of 107 ninth grade students were surveyed. Looks to me like that was 112 right there, so that's not true. Then it says 10th grade, more 10th grade students were surveyed than 9th grade students. That's not true because there are 112 ninth graders and 109 10th graders, so that's also not true. More than 50% of the students surveyed exercised less than 5 hours last week. So, more than 50% of the students surveyed exercised less than 5 hours last week. Less than 5 hours was 107. And if we were to divide 221 and do 107 over 221, that is less than 50%, not more than 50%, because half of 221 would be 110.5, right? So that's also not true. Then it says less than 50% of the 10th grade students surveyed exercised 5 or more hours last week. So less than 50% of the 10th grade students. Okay, so the 10th grade students exercised less than 5 hours. So we're looking at the 10th grade students, so that's 109. How many of those exercised less than, so 5 or more, so that would have been 51, right? So 51 over 109, that's definitely less than 50%, right? Because half of 109 would be about 55, 54, something like that, and obviously 51 is less than that, so that's why this was also an answer. So both of these were the answers, okay? So the next one says event M and N are have probabilities such that the probability of M is 0.4, the probability of N is 0.2, the probability of M or N is 0.56, and the probability of M and N is 0.12. Are events M and N independent? So first thing I want to show you guys is we don't use or statements here. We just use the probability of M times the probability of N equals the probability of M and N. So we're looking at the probability of M times the probability of N. Does that equal the probability of M and N? So that's what we're going to do here. So we're going to say, does 0.4 times 0.28, does that equal 0.12? 0.4 times 0.28 is 0.112, and that does not equal 0.12, right? So no is the answer because the probability of M times the probability of N did not equal the probability of M times N. Okay, so that's why the answer was A. So the next one, it says use the Venn diagram to complete the following sentence. There are blank students in both math club and science club. So math and science, but not the chess club. Okay, so we're going to look at math, and we're going to look at science, okay? But it says not chess, so we're not going to count that number right there, so that's why the answer was the 3 right there, okay? The next one says use the two-way table to answer the following questions. The two-way table shows the classification of students in mathematics class by gender and dominant hand. A student who is ambidextrous uses both hands equally well. So it says, what is the probability that a randomly selected student in class is female, given that the student is right-handed? So what we want is our right-handed total, right? That's going to be our denominator because that's our given part. So remember, I always put the given on the bottom. And then we want to know how many of those were females, right? So that's our 12. So that's 12. Okay, so it's 12 over 23. And that does not simplify, so that is the answer. Our next one says given set P is negative 5, 1, and 3, and set Q is negative 4, negative 2, 1, 2, 3. What is the probability of P and Q? So we're looking for overlap here. So there's no negative 5 in the Q set. There is a 1 in the Q set, right? There's no negative 4, no negative 2 in the P set. Then we got a 3 here, and we've got a 3 here, and no 2. So that's why it is 1 and 3, okay? So what I want to remind you guys, we're going to go ahead and read this problem, then we're going to talk about how to approach it. So it says the guidance department has reported that the senior class 2.3% are members of the Key Club, K, and 8.6 are enrolled in AP Physics, P, and 1.9 are in both. Okay, so this is our key. So our and statement, that means and means both, right? And then we're going to take the probability of one of them. We could do the probability of K. So this would be the probability of K and P, right? And that would mean that this would end up being the probability of P, okay? And this is what we're looking for, because it says, what is the probability of P given K? So here's our given, right? That's the K. We got the probability of the and on top, so we're looking for the probability of P, okay? So now all we have to do is take these measures. So what's the probability of K and P? So it says the probability is 1.9% for both. So that's going to be 0.019, and we're going to divide that by the probability of K, key club numbers, right? So that's 0.023. So we're going to divide 0.019 by 0.023. And when we do that, we get 0.86. My thing is going quiet. 0.826. Okay, which is, if we put that as a percent, 82.6%. And that was the answer. All right, for this next one, it says 5 years after 650 high school seniors graduated, 400 had college degree, 310 were married, half of the students with a college degree were married. What is the probability the student does not have a college degree or is married? So I'm going to create a table for this, okay? Okay, so we've got the students, so it says 650 high school seniors graduated, 400 had college degrees, 310 were married, half the students with college degree were married. So obviously we have married, not married, college degree, not college degree. Okay, so we're going to do, I'm going to do married here and not married. I'm just going to say not M. Okay, we're going to say college, or actually just call it degree. So let's say degree here and not a degree, okay? So we're going to have total here, and we're going to have total down here, okay? So this is our table. We're going to use it to do this. So it says 5 years after 650 seniors graduated, so we got 650 total, right? It says 400 had a college degree. So 400 had a college degree, so how many didn't? That would be 250, right? Okay. Then it says 310 were married. So we got 310 were married. So we would subtract 310 from 650. So that would give us 340, right? Okay. And then it says half the students with a college degree were married. So half of the 400 were married. Okay. So that means there's 200 here and there's 200 here. And then it says how many didn't have a degree, right? So this would be 110 here. And this would be 140 here, right? Okay. Exactly. Okay. So everything adds up the way it says. So what is the probability the student does not have a college degree or is married? This is an or statement. Okay. So does not have a college degree. That would be these guys. So that would be our total 250 over our 650, right? Plus how many people, it says, are married. Okay, so our married is right here. This is our other, this is an actual row, right? So this is going to be plus 310 over 650, and we're going to subtract the overlap. So we're going to subtract this number right here, this 110, okay? Because right now it's counted in both totals, okay? So when we do that, we got 250 plus our 310, and that would be 560 minus the 110 would be 450. So this is equal to 450 over 650. Now what we want to do is reduce that, okay? So 450 divided by 650, you put that in the calculator, right? And hang on just a second. 450 divided by 650, enter, and then we're going to do our math, enter on our regular calculator, and that reduces to be 9 over 13. Okay, now the other way you can do this is you can actually do 5 divided by 13, 31 divided by 65, 9 divided by 13, 56 divided by 65, and see which one gives you the same decimal you got when you divided 450 by 650, okay? Which was, by the way, when I did that, that was 0.6923. So you want to figure out which of those fractions gives you the same value, okay? That's another way to approach that problem. So this last question says, for this question, choose two answers. Which of the following statements about lines L and P are true? So, so let's just look at our slopes here, because it seems like there's a couple statements here about slopes, okay? So if I go over here, I'm going 3 right and 1 up, right? So that's 1 over 3. Rise over run, remember. Rise over run, okay, so that's 1/3. And here, if we go up 1, 2, that would be our rise. And we went over 1, 2, 3, 4, 5, 6, right? 2 over 6 is also equal to 1/3, right? So it says, for the questions, choose two answers. Which of the following statements about the lines are true? So the slope of line L is not equal to the slope of line P. We know that's not true. The slope of line L is equal to the slope of P. Yep, this one is true. The line L and P are perpendicular. Obviously not, because they're the same slopes, okay? The line L and P are parallel. Obviously they are, because they have the same slopes, right? And then the line L and P are skew. Skew means that they have no relationship, neither parallel nor perpendicular, okay? That's what that means. So that's obviously not true as well. And that's it.